everyone, welcome back to another video where today we're going to be solving Leetcode problem 46 titled Permutations. So we're given an array of nums of distinct integers, and we simply need to return all the possible permutations, and we can return this answer in any order. And one very important keyword that we're looking for in this description here is distinct, right? Distinct integers. Every single element within our input is going to be unique than the rest, and that's actually going to be a very important aspect, as you see in our code, right? Meaning the length of the set of nums is going to be equal to the length of the nums itself, right? And so, if you guys aren't aware of what a permutation is, it's essentially a way you can uniquely rearrange all the elements in input, right? And the length of a permutation must be the same as the length of the input, right? And it's basically just how many different ways can we rearrange all of the unique integers within our array. And we simply need to return a list of integrated lists of all of these permutations, right? So basically nested lists, right? So in example 1, we have an input array nums of length 3, containing 3 digits, of course, 1, 2, and 3. And our output would be the array of the subarrays 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, and 3, 2, 1. And applying that same logic here in example 2, we'd get the nested lists of 0, 1, and 1, 0 for the input array nums of 0, 1. And in example 3, we have an input of length 1, and so we'd only have one possible permutation of length 1, which contains the element itself, right? And as you can see, when our input array length is 3, every single permutation that we output is going to be 3, and when it's 2, every single length is 2, and so on and so forth, right? And this applies to any valid input. So we can just have a quick little base case here that I really don't need to explain. If not nums, right? If nums is non-valid or empty, we can simply return a normal list. But I guess in Leetcode, all of our inputs are valid, so we don't really need this base case unless specified otherwise, but it's just good practice to have, right? And now let's actually talk about the backtracking or recursive calling of this problem. So let's just initialize 2 lists first, and one is going to be our final, and the other is going to be so far, the permutation that we're currently building up and looking at so far in this specific current iteration, right? And I can even call it current, but it's a very long variable name, and I don't want to keep accessing that using that name, and so I'm just going to call it so far. And they're both going to be empty lists, right? So the final list is basically going to be dynamically updated as we backtrack or recursively call our backtrack function to build up all the unique lists of permutations or rearrangements of the digits in our input. And the so far list is simply going to start off empty, of course, like the final list, and it's basically going to track one current permutation, one iteration that we're looking at, and then we're going to output that or append it to our final as we keep getting unique different permutations. Okay, so I'll have these two lists that I've defined, and then I'll actually define my backtracking function. I'll just call it backtracking for the case of this. And we don't really need to take any parameters because the only variables as such that we're going to be working with is final and so far, which are already global variables, so we don't need to actually pass them in as parameters. So I'll define a backtrack, and this is what I'll do. I'll have my base case first. I'll have my base case as if the length of my so far, if that length actually matches the length of our nums input, that means we've actually found one valid permutation. And what we can do is we can simply add that to our final. Append array, and I'll just do .copy, or actually I'll do it like this using list slicing, but I'll use the entire list, right? And another very important part is once I've hit my base case, I need a return, and what this does is it simply holds the function. It tells the function that we've returned, we're done with this current iteration of the function, and we can move on to the next permutation, right? It stops executing this function. That's what the return keyword does. Okay, so now that we've declared our base case, this says that once the length of our current permutation that we're currently looking at, once it's hit the length of nums, as we talked about before, that means we found one valid permutation. We can actually add that to our final list of permutations and simply return to exit the function. Okay, so now that we've we've established that base case, let's actually hit the recursive part of this. So we'll loop through all of the unique elements in our nums array. So for I in nums, and this iterator I can be really whatever you want as long as that's not a parameter or the nums variable itself. And so for I in nums, since every single digit that we're looking at is unique, I can simply have one conditional check if I'm using a unique or already used digit. So and I'll do this like this. So if I is not in so far, if I is not in the current permutation that we're building up so far, then we can actually add that to our so far. Okay? And then, actually before I start that line of code, I want to kind of explain. So on line 14, I loop through every single element within our nums array with this for loop iteration. And then I check if I is not in my so far permutation. If I haven't actually used this in my permutation, if it is unique, then I will add it to my so far list. And the reason why I can use not in is you may be wondering, hey, what if I have 2 3s? What if I have 1 3 that's already in my list and another 3 that's not? That would be, false, right? And that's why it's so important that every single element in our list is unique. And since it's unique, this checks if a 3 or a 4 or anything, if we've even used that at all in our permutation, that means we don't want to use it again, and we want to move on to the next iteration or the next element within our input array nums. And if we haven't used it, if it's not in the so far current permutation, then we can add it. Okay, we can add it to our so far permutation, which we eventually append to our final list once the length of it has hit the length of nums. Okay, that means once we've used every single element in our input in a more unique arrangement, right? And once we've added this element, I want to keep doing that until I've hit a unique digit or a digit I've already used. And so what I'll do is I'll call backtrack. Okay, and what I do is when I call this backtrack is I simply keep adding every single unique element, every single unique rearrangement of our current so far permutation, and add that unique element to our so far permutation, to our so far list. And I can keep calling this backtrack function, keep adding until my length actually hits the length of nums. Okay, until my length so far actually hits the length of nums. But there's an issue. I can keep adding, but I'm only going to get one unique permutation, right? How do I kind of get that backtracking, that recursive undoing part of this? And how I do that is I simply do so far dot pop. And what the dot pop method does is it simply removes or takes away the most recent element that we've added to our so far permutation, and that kind of initializes this backtrack or recursive call, right? I keep undoing the last element I've added to explore all different paths or to explore all different unique rearrangements of every single element in the input array nums possible. All right, I'm popping off the element I just added to see the next element to add. Right, that's what this pop does. For example, if I have an array 1, 2, 3, right, I've added 2, but I still have a 4 maybe in the 5th indice. Right now I'm just at the 3rd indice, right? I have a 4 maybe at the 5th indice, right? I haven't used this 4 yet, but let's say that I hit, another 3. I don't want to use this 3 again. So what I'll do is I'll kick out this 3 and I'll add a 4. That's another unique permutation, right? And so on and so forth. Then I can add 3 after because I haven't actually used that yet. Okay, it's something that's not in my so far array. Since 3 was already in my so far, I want to add a new path. And so I'll pop 3, I'll pop the most recent element like this, and then what I'll do is I'll add the 4 in. Okay, and this is another unique permutation. All right. So now that we've kind of established what the pop does, then I can simply get out of my function, right? Get out of my function, and I can call the backtracking function. Once I call the backtracking function, I'll have dynamically added every single unique permutation or rearrangement of the digits of the input array into my final list, and I can simply return my final. And if I were to submit that, unless I made any syntax issues or something, this should be completely fine. Res. Don't know where I have res here. Okay, this should be so far. Sorry, I've been using res as my variable name, so for the past few problems, so I'm a little bit confused on which variables to use. But as you can see, it's pretty efficient, and it says memory-wise it's not too efficient. But if I were to submit this again, it would completely change, right? And so you really can't trust these beats /% of users on Leetcode. It's really just completely random. Right, so if you guys learned something new, from this video. Please make sure to like and subscribe. It really means a lot, and I will see you guys in the next video.